The opportunity to present the research. My research is say that the survey of Japanese enterprise to analyze the motivation and the strategy of the Japanese enterprise toward the climate change goals. So the title is how business strategy and activity for mitigating climate change influenced by the social pressure. Okay, recently, company feel the pressure to make the further long-term commitment toward the 2050s. Particularly in 2017, TCFD, organized by the Financial Stability Boards, to recommended the company to consider the risk and opportunity to establish strategic plannings. TCFD recommendation is voluntary, and however, many companies support this recommendation. One question is, when the company pursues these tasks, how they were influenced by the social pressure for their action. The previous survey showed the role of social pressure on the company's motivation toward the climate change actions. Although the many previous studies examined the factor already, it is important to identify the factor influence companies' long-term commitments in comparison with the general CO2 reduction activity. That means that we suppose that there is a different motivation between the kind of setting a target or like, to establish a vision and the current energy savings or to general CO2 reduction activities. So because long-term commitment for the 2050 requests company to implement evolutionary business change, the difference motivation can be exist from the conventional CO2 reduction activity. In this survey, we try to demonstrate the comparison of motivation between the general CO2 reduction activity and long-term commitment toward 2050s. Before to showing the survey data, I just want to introduce the theoretical backgrounds. According to the institutional theory, company behavior is affected by the three factors, namely, regulative pressure and normative pressure and cognitive pressure. First, regulative pressure is the pressure from entities that company depend on, such as governments, as well as the supplier and the customers for the company, which affect the behavior of actors by altering benefit or costs. Second, normative pressure is the pressure to impose the constraint on the social behavior as a society and community. The third, cognitive pressure includes a variety of elements such as imitation, mimic process, or goal creations and solidarity. So we think these factors are related with the motivation within the company, namely the internal pressure. Among institutional pressure, previous studies show that the normative and cognitive pressure are effective. A survey of, for example, a survey of 394 companies that were part of Global Compact indicates that normative and mechanism of institutionalization influence corporate decision-making. Cognitive pressure is based on the reputation, which could influence a company's climate action. For example, a company might join the GRI simply for the purpose of the reputation management. Reputation management is one of the key elements inside the cognitive pressure. Previous studies show, for example, that Hana et al. To explain that the difference factor exists between the short-term activity and long-term vision. The comparison between the short-term and long-term policy by empirical analysis, Bosti et al. Report that they are similar. Conversely, the other researcher demonstrates that these two types of action are not connected, and they are characterized by the different underlying motivation. So there is some kind of different opinions. So examine whether there is a different factor between short-term and long-term. This is survey methods. Survey target is a company whose sales volume were greater than 100 billion yen, equally that the like 1 billion US dollars. So it's a big company. Company's data set is Cosmos business data from Teikoku Data Bank. Teikoku Data Bank is one of the biggest database companies in Japan, a comprehensive database of Japanese company. A total of 1,714 companies made a list and were sent questionnaire by mail in May 2019. So we received the 241 company and by the mid-July 2019. This is general findings. The majority of company responds that addressing climate change is part of mission of their company. And in fact, 77% of the companies rightly to strongly agrees that part of the company mission is dealing with climate change. This suggests that climate change related action has actually become a business value. Other business priority, the environment or social issue, customer relations, and efficient use of material and resources were perceived as having a close relationship with climate change related action. This is a questionnaire, the dependent variable. We set the general CO2 reduction activity, such as CO2 reduction effort through the business activity, the development of products, or transfer of low carbon technology, or requesting CO2 reduction from a business client. As for the long-term commitments, that includes the setting quantitative target, showing CO2 reduction plan, having substantial measure, having plan reduction target right, or establishing long-term vision. And the questionnaire as independent variable, we set the 4 questionnaire so that the by whom does conducting climate change request, by government or internal company or client customer or by communities. So by government means a regulatory pressure, and by international companies means cognitive pressures, and by the community means normative pressures. So the role of social pressure by 3 elements, regulative, normative, and cognitive pressure as an independent variable. the factor promoting general CO2 reduction activity and long-term commitment as dependent variable. So, so that to examine the factor promoting general CO2 reduction activity and long-term commitments, we used the ordered logic models. This is a result of the empirical analysis. The results show the government pressure to affect the activities and long-term commitment. Internal pressure affect the all activities, something like that, and commitment. Requests from the clients seem to mainly affect general activity, right? And the community pressure affect the products and supply chain and long-term commitments. So this indicates that the CO2 reduction in the business activity can be motivated by the clients. And this is in line with the argument in the previous studies, who found that the stakeholder pressure is the driver of climate strategy. The results also show that all pressure have a strong influence. However, they do not equally influence dependent variable, right? There is some kind of difference between the general CO2 reduction activity and long-term commitments. So according to the instance theory, company behavior is affected by three factors. First of all, that the role of the government. The results show that the pressure from the government affect long-term action, including vision setting as well as the general CO2 reduction activity. However, previous studies showed that the government does not affect the company's activity. This result is not coincident with the previous study. I think this is because the voluntary action plan in Japan have been conducted under the guidance of the government. So in Japan, the government guidance is very influential on the company's attitude. Long-term commitments are supposed to be affected by the regulatory pressure because the government sends various signals to companies to achieving the long-term climate goal. The results show the company feels pressure by government. However, in fact, companies do not regard the government instruction as an incentive. It's a little bit curious. So because considering long-term vision, there are a lot of uncertainty, so that each company have to consider that vision by themselves through the establishing governance strategy. This is the TCFD final recommendations, structure. So TCFD recommend show the governance in the company is crucial. So as for the normative pressure, social and community pressure affects the product supply and long-term action. This is coincident with the previous studies. Cognitive pressure is the pressure to imitate competitor and create a goal. So Japanese company are said to follow this pressure in particular because the Japanese company is very keen to the attitude of their competitor. So these pressure usually come from the international source. A strong international pressure creates implicit mimetic pressure. So this result also coincident with the previous studies. International pressure affect all variables, including long-term action, but weak with the CO2 reduction activities. Concerning the role of client and stakeholder, clients do not affect the vision setting. but international pressure strongly affected, which may indicate that the vision setting is an internal task of the company, not an issue of the client, means outside. So requests from the clients affect the general activity and target setting. This result does not coincide with the previous studies. However, previous studies only deal with the general CO2 reduction activity. In Japan, the client is influential for the company activity in every day's CO2 reduction, but not in the long-term vision. For example, in Japan, customer is regarded as a god, right? The customer is to the unique to status to the company to respect. So, but just this phenomena is applied in the only in everyday CO2 reductions activities. So, conclusion. These results suggest that to facilitate the long-term commitments, companies are feeling the pressure by government, community, and internal the pressures. This implies that all the elements of international theory could be the motivation for the all activity and actions. And particularly that to achieve the long-term goal, the government and community can be provided to put the pressure to promote long-term commitments. On the other hand, companies face many uncertainties such as complexity and volatilities and uncertainty and ambiguity. So to achieve long-term growth, the company must consider their respective vision to promote a long-term commitment. So thank you for the listening. Thank you.
Thank you, Shiro. If we can move to questions. If someone has questions for Shiro. Yes, Carsten, go ahead.
Okay, thank you. Thanks, Shiro, for the interesting presentation. So that's quite an interesting data set that you have, I think. I have one question. You spoke about the influence of clients. And my question is, did you observe any difference between B2B and B2C companies? So companies selling to businesses and companies selling consumer goods. I could imagine that there's a difference maybe in the influence of clients.
That's a very good question. Thank you. Okay, that's a very good point. That I think that generally that we suppose that B2C that the company is very keen about the that the response by the client. So actually that I don't to examine the difference between the B2C and the B2B. So but okay. Actually, that in other sub analysis that I check the difference between the sector, like manufacturer or through transportation or retail and for etc. And say
yeah, maybe this is something you could try out of your data set. You have a very rich data set, and just doing a simple test between the two, maybe is interesting. Could be.
Oh yeah, thank you very much. So that we will to do that in future.
Okay, thank you.
I have also one question, Shiro. Thank you again for the presentation. And were you able to match your results in your data with actual actions from actual observations and actions from the firm, from the enterprises, like imposing an internal carbon price in the company to guide investment and development strategies?
Yes, thank you. Very good question. That yes, like actually that I recognize that such a point like internal say that the governance structure, including the international pricing the system, is very influence that I read that some literature that to examine these points. So but I think that in this survey that a question about the internal pressure means like the pressure from the president or something like that. So I think that it's not mean that like international the carbon structure. So maybe we needed another the survey that
actually I meant yeah, not international but internal
internal internal,
okay. Thank you for your answers. I think Carsten Herbes has another question.
Another question. I guess it makes probably a difference who answers your survey, who participates within the company. So a company of $1 billion turnover, probably many people could answer. Do you have an idea who answered it? Was it more people from sustainability department, or I don't know, strategy department, planning department, or assistant of the CEO? Who are the people who answered your survey?
Oh, very good question. That's I checked that which department to send the answer, and but actually it's a variety. There are a variety of department. One group is a kind of public relations, and one group is strategic planning. Like, or another group is a kind of environment strategy, something. Because I think that, for example, like even that that the responder is a public relation people does not know that such a kind of the information. So just the public relation means a kind of window, right? So yeah, so that they they to ask the one by one that each to the question to the concerned the department. So in the case of public relation department, we cannot identify which department is play a role. But in case of the the strategic planning department, maybe that I think that it's a kind of this kind of company is thinking that the climate change is very serious, or like a center of the like a business planning, right?
I see.
So so that I think that that your question is very important. That so we maybe we can identify the company's attitude to by which the department is dealing. this was.
Yeah, thank you. That's an interesting observation. So we see the same thing here in Germany. So for some companies, sustainability and climate change is more a communication and PR thing, and for others, it has become a strategic issue. So, okay, thank you.
Thank you, Shiro, and thank you, Carsten. If someone has another question, please ask. So if it's okay, maybe we can move to Joe's presentation. Okay, so we will move to Joe's presentation. Are you able to share your slide, Joe?
The host has stopped it. Hello.
Yeah, you should be able to share your slides. You have the rights to share your screen. Perfect.
Hello, can you hear me and see me? Am I good to go? Hello?
Yes,
Yes,
we can see
you can go.
Okay, great. All right. Okay, so thank you, first of all, for giving me this opportunity to speak my mind. Unlike the previous speaker, mine's very much an analytical presumption, I think. But I'm extremely keen and determined to show that endogeneity is really important in the take-up of carbon technologies. So in the context of this study, I looked at two studies, the 2018 INRAE and Argudes, and then the Quentin presentation. And I think they both start with the assumption of a certain industry structure. For instance, I think INRAE says there's a competitive firm, a large firm and a fringe firm. And then they analyze how market power in the permit market causes endogeneity and take up of technology. So I just say, well, I think the converse, I go for the converse. In other words, I say that I'm going to assume that it's a rivalry for market share and interdependence between firms that promote strategic behavior and bring about endogenous industry structure, such as a dominant fringe and a fringe player or mergers. So in my analysis, the potential to gain market power brings about investment in abatement technologies and market structures consequently endogenously determined. So I start with several assumptions and they are exogenous. Firstly, I start that I don't really use concrete examples of environmental policies. In other words, I don't go into the issue about whether we're talking about tradable permits or carbon tax. It's irrelevant. All I say is a previously unregulated environment is now regulated. And the proxy for that is simply that an output, a unit output of a theoretical good A is now therefore going to be costing more because the environmental cost is implicitly taken into it. And I imagine a situation so that the output cost can be disaggregated from the total cost, and you have C output and CE, and that in an environment, in a regulated environment, I say that the regulated cost is higher than otherwise. And then I further talk about environmental regulation, again, in a very abstract way. And I have this term, it's called the alpha term, and that determines the tightness or looseness of the environmental regulation. So if I want carbon tax to be higher, then clearly I would say that alpha is higher, or if I want tradable permits to be much more stringent so that the price of carbon or any other externality is higher, then I use the alpha factor as being higher. So then I imagine that they've got two technologies, old technology and a new technology. Old technology would be an example for concreteness, like a coal-powered station, or a new technology, which might be, you know, a wonderful exemplary green technology, such as one in which uses gas or hydrogen or solar or wind or tidal powered stations. So the two parameters of new technologies are, first of all, the cost of the technology, which is R, and the effectiveness of the new technology as measured as little f, where f has a value of 0 to 1. And the f can be as little as 0, or in other words, it's completely useless, or it can actually reduce it. So somewhere in between, I use this measure to determine or say that capture the effectiveness of technology. All other studies do the same, and I've kind of followed suit by doing this. So if we imagine that if this good is produced by a monopolist who doesn't have to worry about anybody else because he's the sole producer, then I argue that the effort that he uses to reduce cost will be such that he will just do that until he reaps the benefits of cost reduction and internalize all benefit from cost reduction. The other assumption I need to make is about the good in question. I assume that the public knows, or then everyone knows, it's common knowledge, that a good that is produced by the new technology is a good good. In other words, more of that good is preferred to a less good. And a bad good is when it's produced by the old technology, and less of that good is preferred to more of that good. So that's a strict economic preference ordering that is implicit. And I'm assuming that the monopolist knows that unless he uses a new technology to produce a good, then his demand is not going to be, I mean, there's going to be some contraction of the demand or public reaction, etc. However, let's see if, and then I take this issue to a duopolis and see, okay, so the standard Kuno model assumes the parameters for demand and the cost. I use a constant cost structure and a measure of market size. So we start with a Kuno non-cooperative equilibrium using the intersection of the reaction curve model. And we have those parameters, price and quantity. And then we also assume that the cost, there's no existing cost differential. So there's no, everyone's in equilibrium, they've got equal share of the market. But however, there is a possibility that one firm can reduce their cost relative to the other and then enjoy greater sales and a greater market share. And that's represented by the Lerner index of market power. And I use this to initiate my game. It's a normal form game. We have got two firm duopoly, X and Y, two strategies. Strategy 1, use technology, old technology. Strategy 2, use new technology. Strategy 2 involves the cost of R, and it also, but it implies that you have a lower cost structure than the other in a carbon constrained world. In other words, when carbon is taxed. And this is where the cost differentials will matter more in a tighter environment compared to a looser environment. So, so that's the payoffs. The payoffs are simply total revenue minus total cost. And X11 represents the case when neither of the firm uses the new technology. X12 represents the case when one firm uses it and vice versa. And X22 when neither of the firm uses it. So that by symmetry was implicitly Y11, Y2, Y21, Y22 are the same as X11, X1221. Okay, so this is the normal form game. And also the blue lines X21 and X22 are where the R factor or the cost of the technology has to be removed from the profit because they're the only times when the firm using the technology incurs this cost. So I do the payoff calculations as using Kuno calculation, price total profit is equal to total revenue minus total cost. And then we look at when the R is equal to 0, or assuming that the technology is being given away, then the payoff ordering is as follows. So we state that in that form. So the larger bars under means greater returns. So in this case, for example, we find that the dominant strategy is for both firms to use the technology because they're all best off in this situation. Okay, but R is never 0. It's not realistic to assume that's 0. So we need to change the value of the R. And to do that, I use a spatial representation, which shows that as this indicator moves, you find that the payoff ordering changes for different places. So we have the critical values of R that gives us this ordering. So what that then leaves me is to then see that as the ordering changes, we get different solutions to this game. So when R equal to 0, we can see that the firms are better off using, both firms use the technology. And that's a great result because then all of good A is produced using the new technology. So we assume then that all of the externality is internalized. But then we find that in matrix B, where the cost is other than 0, greater than 0, and we start creeping up, we find that a really interesting situation, because if neither use the old technology, they're in cell number one, neither use, beg your pardon, neither use the new technology, then they're all in cell number 1. But then that's not a very stable equilibrium, because one firm has an incentive to use that new technology and increase their market share. Again, there's an assumption that there's a strict preference for goods produced by using the new technology. And so this, we say, is the dominant strategy, however, ends up using technology. But this is where we find that the group outcomes are not the same as individual outcomes. So this is the interdependence, which I would like to focus on. And the same with matrix C. At this particular cost, we find that strategic behavior can take place because this is a non-cooperative Nash equilibrium. And this also gives us a prisoner's dilemma when both firms use the technology and both are worse off. And this is the area that I'd like to focus my attention on and make the case that it is here that we can get strategic behavior. It's here that we can get first mover advantages. Matrix B and matrix 6 leads us to a scope for strategic behavior. Or if there's aggressive behavior in the use of technology and everyone's worse off, then there's scope for cooperative equilibrium, as in mergers. And then we have matrix D and E, where the cost is high and neither of them uses the technology. So then I asked the question, so the interpretation is that if the good A is produced in a duopoly, unlike in a monopoly, abatement technology will be used as a strategic variable to gain market share. Uncertainty and the risk of losing market share to rivals cause investment into abatement technology despite potential losses in margin from investment. Good A is likely to be produced using NT, and changes in market structure occur at some cost of technology, even if the investment makes the players worse off. So then I try to extend this to an N-player oligopoly. So I use the 2 linear cost strategies again. And this time I say that the new technology has greater modular efficiencies and reduces externality, but it incurs a greater fixed cost. So, but I also use a smooth demand curve, and I use N is greater than 2. So these are the profit maximizing conditions that are typical, that are standard in economic analysis. So, so we say that because if N is greater than 2, we say that as the cost of B increases, then firms are either worse off or better off in using that technology. But I would like to focus on the 3 phases in the N equal to greater than 2 case, and because it mirrors the n equal to 2 cases. So when the cost of technology is really high, no one benefits because no one uses the technology. Profit for strategy number 2 is way below that of profit of using the technology. So, but in a medium, we get when the costs are medium, we get environmentally beneficial outcomes. So this is where, again, we have some sort of industry structure happening, because the number of firms that would take on the technology can make a difference to how the industry then comes out. Either you can have large number of firms, large number of small size firms, or small number of large size firms. And this is where I argue for endogeneity. And again, when it's low, produces benefit, that's really a no-brainer. We don't have very much to say about that. So in summary, I've modeled 2-player and player strategy. They compete for market share, and I've tried to demonstrate or aim to demonstrate interdependence in the use of abatement technology. And I tried to prove again, or I aim to prove that first mover advantages, Prisoner's Dilemma can bring about changes in industry structure for some cost of using the technology. So then the argument is, what does it all mean for policy implications? Well, I think the strongest case is to realize that environmental policy should be industry specific, not one size fit all approach. The size and numbers of suppliers in the market is a key consideration on deployment decision. And I think the strength of my analysis is that the cost of investing was actually calculated in terms of all the parameters, the supply parameters, as well as the demand parameters. So depending, and also of course, its elasticities and where the good is produced. But I have simplified all of that for the analysis and leave that for future work. So if abatement technologies are given away, the cost of deployment is zero. Suppliers uptake the technology readily, and society benefits. And so all of the externalities reduced with very little cost. There's no uncertainty in the environment, but this is unrealistic because it means you need to subsidize the use of technology, and it means that actually means you have to tax someplace else. Or alternatively, by artificial means to make the technology so effective that investment costs in relative terms become negligible. But when the cost of technology is high relative to demand and supply parameters, no firm takes up this technology and society is worse off. Environmental policies can be used to effectively reduce the cost of using the technologies, either through subsidies or encouraging innovations to reduce the cost of uptake. Alternatively, for these governments, if we want these industries to persist and we still want to have good environmental outcomes, then they will have to allow leniency and greater tolerance for these industries. But it's the intermediate cost that becomes a potent strategic variable. At this cost, firms industry take matters into their own hand. They become active participants in the deployment of abatement technology because of the desire to gain market share and a competitive advantage over rivals, becomes the incentive and driver for adoption of abatement technologies. Firms in these technologies may in fact deploy technology to their own determined Prisoner's Dilemma outcomes. And policymakers can identify what costs of the technology should be to bring this result, because Prisoner's Dilemma outcomes actually brings about very good social outcomes, in my opinion, at least. So finally, the extent to which firms in an industry invest for the purpose of reducing externalities in production activities is firstly dependent upon industry structure, behavior of their competitors, the tightness and looseness of environmental policies, the effectiveness and cost of technology, and these together can bring about endogenous changes in industry structure due to rivalry and competition for market share. In my future research, I would like to see if I can validate any of this theory using case studies or empirical data. And that is all I have to say. Thank you for listening. Hello.
Thank you very much, Jo, for this presentation. Does someone have any question to Jo? So maybe I will start. I have one question. Do you, in your model, or maybe in parallel, did you imagine any kind of dynamic framework you could extend your model to, so that you can show that cost can evolve, for example, with learning effects when the new technology is adopted by one or more actors, one or more firms, and then these decreased costs can change the equilibrium of the game you presented.
Okay, I think what you're referring to is spillover effects. So that when some firms use the technology, there's learning, and then that in fact reduces the cost of using the technology.
Yeah, exactly.
I think that's a very good approach. Yes. Yes, this is a very simplified model. I really wanted to see if it was if my thinking was valid and rational, and that's what I'm looking for feedback. Yeah.
Okay, and do you have ideas of industrial sectors you want to apply to, like maybe a national energy sector of some sort?
Yes, yes. I guess immediately the electricity industry will be the one that would be obvious, because you can check for coal generation versus other technologies. But I think I'm interested to see more at what cost would actually cost them. What would be the driving point? Where would the switching behavior take place? So that was my thoughts on that, but I haven't really, and also I would like to look at some cost functions and see if that will work. Have I answered the question?
Yes, thank you. Don't hesitate if you have in the audience, if you have any other question for Joe. Okay, so if there are not, once again, thank you very much for this very interesting presentation, Joe. And maybe if you all agree, we can move to the last presentation, mine. So, are you able to see my screen? Is it okay?
Yes.
Okay. So thank you very much for being here. So today I will be presenting a joint work with Quentin Hoarau concerning battery recycling in Europe, and the focus on mineral needs, mineral demand for battery recycling, and what the European Commission has to say and had to say this last month, this last year and this last month about this topic. So basically the idea is based on a 2020 European Union Commission proposal, which in fact was tackling the fact that the battery sector had to be regulated more in the European Union, because basically the current regulation is more or less based on the previous state of the battery sector, which was more focused on lead batteries, for example. So this EU Commission proposal is focused on 3 points. The first one, the most interesting one in our paper for our topic, is that the European Union Commission imposes use of recycled material goals for years 2030 and 2035 for 4 minerals that they assume to be prominent in terms of strategic use and eventually environmental and social constraints, which are cobalt, lead, lithium, and nickel. They also fix recovery objectives for lithium and ion batteries, and also carbon footprint constraints with thresholds not to go beyond. However, the question we ask ourselves is that given that there is a time lapse as batteries are durable goods between the production of the battery and the end of life of the battery, and we have a lot of technological changes in the sector because the sector is very dynamic in terms of technical change, in terms of market growth. Are the proposed rates from the European Union Commission's realistic? So first, I will tell you a bit more about the context of this study. So the main point of this context is obviously the fact that lithium-ion batteries are driven in a very growing sector, especially led by the electric vehicle market. So here you can see from the data from the International Energy Agency that you have an exponentially growing sector. And this key element is also backed by costs for batteries that are pushed downward, so almost divided by 10 in 10 years, as you can see, from more than 1,000 US dollars per kilowatt hour up to 150 US dollars per kilowatt hour last year. So these two elements make that lithium and ion batteries are a very fast developing sector worldwide. However, and this is especially mentioned by the European Commissions, this sector lays many questions regarding its sustainability. Let's say the first sustainability issue that is raised concern environmental impacts of the battery. So you have important environmental impacts linked to the mineral extraction. So this includes both the use of the intense use of energy for mineral extraction, as well as the use of other resources such as water for lithium, for example, especially in regions where there are also already hydric stress. And at the other end of the chain, value chain, you have end-of-life management issues where lithium batteries are a growing stockpile and have to be managed for the end of life in order to avoid any bad externalities linked to waste accumulation. You also have social impacts, especially for mineral extractions. You can all think, for example, about the issues raised by cobalt mining in Congo, in Africa. You have then sustainability concern that relates more to the availability of the resource, as in many cases these markets are very concentrated. So the European Commission lays that there are risks of supply chain stress along the road for the development of the industry. And then last but not least, at the EU level, the industry is not yet very sufficiently enough developed. And to answer these questions, the European Union has put forward two initiatives. The first one will be the European Battery Alliance, started in 2017, which goals is to promote the battery industry and structure and promote the battery industry in Europe. And the second one is the first mentioned European Commission proposal that tackles these environmental and sustainability problems of battery manufacturing and battery waste. So this proposal is actually an incentive to invest in batteries, to develop recycling, and to contain environmental and social challenges. So it's architecture around these 3 points. And we can already see that recycling is actually central in this proposal. So it is directly tackled in the second point, but also can also be linked to the third point related to containing environmental and social challenges. And the one point that does interest us very much here is the 3-step requirement regarding the use of recycled content in battery in Europe, meaning that started in 2027, we should have a mandatory declaration of the use of the cobalt, lead, lithium, and nickel. In 2030, they would impose a ratio of recovered materials, and they would impose 5 years later even more stringent ratios of these materials. Regarding lithium-ion recycling, it is put forward in the EU eventually recently, and you can see that from the development of many recycling facilities in Europe. And for example, the Northvolt Health, which will open, which is a very big one, which will be opened in next year, actually. I already mentioned that, but there is also the European Battery Alliance, and also that the Commission is trying to answer to the many environmental and supply concerns of the battery sector. However, we see many threats to the development of lithium-ion recycling. The first one will be that you have already a lot of technologies that do exist and that have important market shares for the cathode of the battery, especially. So many technologies with various mineral compositions. The second one will be a question about the economic profitability of the recycling process and how it will be answered by the growth of the sector. And then you have also many different recycling processes with different results economically, but also different results in terms of what you can recover from this process. So you have an hydro recycling or pyro recycling, for example, that are the two main processes already existing. So now you can see here that you have a different material footprint of the different technologies for the batteries, as I said earlier. And the objective of the paper is that we want to compute the availability of the mineral resource for recycling in the European battery sector, taking into account the fact that batteries are durable goods in the economy. You have a projected growth of electric vehicle sector, hence of the battery sector, and you have a possible technical change for the technology of the lithium-ion battery. And we use for that data from the International Energy Agency, and we interpolate their projected scenarios. And we check if the European Commission is realistic. So we relate to literature on First, prospective analysis that are more focused actually on prospective, long-term, and worldwide assumptions on the availability and the demand of material for battery manufacturing. We relate to obviously techno-economic analysis, especially for the data we use, and then we relate to resource economics papers that already tackled the fact that recycling is a way to alleviate both scarcity concerns and also environmental concerns regarding the use of minerals in industries. So in our paper, we show that the European Commission's batch recycling rates are very optimistic, and some are missed, especially for cobalt recycling. And when they propose a more ambitious scenario for the energy transition, it leads to actually lower recycling ratios. We also show that the fact if we model battery lifetimes with longer battery lifetimes, it implies that it will be harder to reach these recycling objectives. So we have a dynamic flow model here, and we use data from projections that we interpolate from the International Energy Agency reports. So interpolations of EV sales, of the market shares, and also we compute the material composition of the battery cells. And we also do assumptions on the battery sizes from international IAEE reports, and we parameter the survival functions for batteries. So as you can see, you have a shift in technologies, and this shift, so it's not visible here, but this shift mainly concerns a global change of technology from cobalt and manganese-based batteries towards nickel-based batteries, with also the rise of technological shift with solid-state batteries. These are our extrapolations for electric vehicle growth based on the two International Energy Agency scenarios, the STEPS one and the SDS one, which is environmentally more ambitious. What we do technically is that we aggregate the flow of material for at each year in the sector, taking into account all the parameters for the sector. So we submit for every usage of electric vehicles and every kind of battery. And then we project the recycling potential, taking into account a probability that we based on a variable distribution. We calibrate with the lifetime data of the batteries. And with that, we compute the available waste flow each year from the previous cohorts of batteries that have been produced the previous year. So in terms of results, first, we compute the material demand in our model for Europe. So you can see that from the STEP scenario to the SDS scenario, you have almost results in material demand that are multiplied by 2. And this will be important in terms of the results for the ratios of available recycling afterwards. This leads to the following available waste flow that are less different than this previous material demand rise. So the difference between STEPS and SDS is less important because you start with actually a more similar use and demand of material for the first years of the decade 2020-2030. And then we compute the waste on demand ratios. And here you can see that when you have a more ambitious, environmentally more ambitious scenario for the development of the sector, you actually have recycling targets that are more difficultly attained. And the fact is that you start your scenarios with similar demands between, let's say, between 2020 and 2025, and after 2025, you have an exponentially more important growth in the case of the sustainable development scenario that leads to higher demands in minerals, and then higher potential, lower potential recycling. And after doing so, we focus on our three policy objectives. So we do not include lead, obviously, because it's not a concern for lithium-ion recycling, But we look at the objectives for lithium, nickel, and cobalt. So the first thing we can say here is that for cobalt, the European Union Commission suggests a very high objective of 12% recycled material incorporated, which leads to unattained objectives in 2030, both in the more ambitious scenario, the SDS scenario, and the STEP scenario, which is the state policy scenario. We also see that for the nickel, it's hardly attained for the SDS, the sustainable development scenario. We can, when analyzing these results, we can think about what we observed in terms of the market share of batteries, as we can see that there is this early shift from cobalt and manganese to nickel batteries. And this early shifts leads to cobalt with this high objective that is very soon not less and less used in the industry. And on the other hand, you have the same reasoning for the opposite reasoning for nickel, where nickel is used later in the industry and so is not so much available in 2030. Some additional remarks here. So the ratios we show here have also to be mitigated by the fact that recycling efficiency does not have to be 100%. You can have leakages, losses in the process in terms of batteries leaving European Union, for example, but also technical losses in the process. For example, with some recycling methods, you have some mineral losses. And also, we also tackled the case of companies having the strategic choice to reach the goal of the recycling goal only by 2030. And so stockpiling waste batteries up to 2030. And we show with this strategy that the recycling objectives are met, and in the end, this strategy also has to be questioned for the fact that what happens after 2030. So you started with the stockpiling of waste material, and then you have to move up to a year-to-year recycling analysis, as we did before. And as a reminder, there is also a 2035 target for recycling given by the European Commission. We also did a sensitivity analysis on the lifetime of batteries. And we can see, and it's not a surprise that when we raise the lifetime of our batteries, so we used 10 years as the most probable duration for the lifetime of the batteries, and we see that when the lifetime is higher, obviously you have lower recycling ratios in 2030, as the battery minerals are later available. And so this raises the question of what about technical change that has an impact on the life duration of batteries between now and the European Union Commission objectives of 2030. So now I will conclude. So first, as I said, what the European Union Commissions propose are very optimistic targets for the incorporation of recycled material in 2030. These very optimistic targets are especially true for cobalt recycling. However, we can maybe mitigate this result by saying that cobalt is bound to be, the use of cobalt is bound to be reduced in the following years and replaced by the combination, the use of nickel-based batteries. You also see that paradoxically, if you have a more ambitious, sustainable scenario, it will lead to lower recycling ratios as you have a higher growth in material demand, in mineral demands. You also can notice that the longer the battery lifetime implies that it will be very hard to reach the objectives. The batteries will remain in use for longer times, and the materials will not be available for recycling in 2030. And maybe we can also wrap it up by saying that the way the European Commission is focusing on in this proposal is more based on the strategic aspects of the policy rather than the social and environmental aspects that are very present when we tackle the mineral demands for lithium-ion batteries. And it's more focused on the risk of scarcity or the risk of the stress on the supply chain of these minerals. And then further work can also be, will be to extrapolate up to 2035 to check what will be the step 3 objectives. And also maybe we could test also more ambitious technological scenarios where we will have an important technological switch. For example, the introduction, very important introduction of solid-state batteries that have very different mineral characteristics than the manganese, cobalt, and nickel-based ones. And that will be all for me. Thank you for listening.
So thank you, Etienne, for your presentation. Before going on with the questions, I would like to remind the speakers, so Etienne, Joe, and Shiro, to upload their presentations on the dashboard of the conference, and then we can go on with some questions. So if there is any question for Etienne. Yes, Yannick.
Hello, Etienne. Thank you for your presentation. It was very interesting and attractive. So congratulations first. I have a couple of questions or remarks on your presentation. And could you go back to slide 8?
Yes.
Please, because you go fast on that slide, and it was, I think, a pity.
Up.
So, slide.
This one?
Okay, this one. Big. Okay. Okay, it's not what it's based on that idea of footprint of the technologies, but also that the fact that when, let's say, to make the evaluation of the recycling, your strategy in the paper is to start in 2020 and to see what would be the strategy over 2020 to over 2030 and 2035. And my first question is, why don't you start your reasoning with the uptake of the electric cars 10 years ago? Because the stock of battery did not start in 2020, but let's say that in 2012 we start to have some cars sold, and if we reach today 2 or 3 millions of cars, it's because we have sold them since 6, 7, 8 years from now. So why don't you start your calibration model 5 years ago?
Okay.
Would it change something to because in fact in the last 10 years, but it's a two-sided question. In the last 10 years, we have changed the composition already of the batteries. At the beginning in 2012, the batteries were very cobalt rich, and today they are less rich in cobalt, and of course in the next 10 years it will change as you mentioned it. But the value of the value of the first batteries of 2012 and 2013, 14, 15, which are very cobalt rich, makes them very attractive to recycle.
Right. So let's say first, so we had this discussion between should we recycle it year after year, or should we wait for a stockpile of batteries and then recycle to meet the objectives? And we decided to focus first and mainly on the year after year recycling, as it does not imply strong assumptions on the strategical behavior of the companies. That will mean that they stop for a while. They don't start recycling, let's say, after a couple of years, and then they start recycling when they reach, let's say, a threshold in terms of accumulated batteries. And so this would have a very, let's say, important strategical, important strategical assumptions regarding companies. And also, it will also mean important costs in terms of stockpiling, and then going back to the stockpile of waste accumulation. And it's actually so. In previous studies, I'm more focused on recycling economics, and it's actually a very important question in recycling economics on whether you can easily and at economically with economical profitability go back to a stockpile that has been accumulated years after years. And it raises a lot of questions economically, but also the feasibility in terms of how the material will be degraded years after years in the stockpile. And then also maybe we can also add to this answer this graph showing that you have between 2020 and 2030, you have a very important growth this exponential growth, and this exponential growth is also present between 2010 and 2020. And this means that apart from already important fleets of batteries in place worldwide, this will be still very small compared to what is the expected growth between 2020 and 2030. So there are those elements to your question, to answer your question.
It's a perfect answer. Then I have two additional questions. The first one is, did you consider the second use of the batteries?
So for the second use of the batteries, so I did not mention it during the presentation, but this will be tackled actually when we analyze the sensibility on the lifetime of the batteries.
Because what I heard from companies, but I don't know if it's true, is that the thing that we are going, it's Renault's information. They say basically that they think that the battery for the car could last 10 years. And that after there is 10 more years for second life usage. And only after 20 years, you need to recycle them, the third life.
Well, that's why we did. So actually, there is a mistake. This is between 8 years and 15 years. We tried to see the impact on the life duration of the impact of lifetime duration of the batteries, and in our opinion, it was what will be reflected when we consider second use of batteries. But actually, in one study we cited in the literature review from a study from Xu and co-author, I think, they also do these assumptions using lifetime duration of the batteries for the second use, but they use very more important, if I remember well, they use more important lifetime, up to 20 years, I think.
In fact, it is logical, because in fact, when you use them in second life, you use them less, and the duration could last more. Because they are used as backup, and as backup they are used less frequently than for mobility purposes. So I think 15 years is a bit underestimated. You should probably extend to 20 years.
Yeah, but actually, as we can see here, already for 15 years, we have very low recycling targets in 2030. So I think we should reach 0 if we extend it to 20 years.
Yeah, but I think it's worth the cost, because it tackles a reality of usage. So here, when you use 15 years, it's okay for your numbers, because you prove that up to a certain threshold, the value is close to 0. But in fact, if you want to stick with the practice, you should go for 20 years. But it's just maybe to add a line, not to cancel the 15 years duration, but just to add a line on 20 years, and you could explain that it's basically the expected maximum duration. And then I have a last, the last point is, but I don't know if it fits in this work, but it will be probably a point that some people will to have the answer, is the risk exposure of these problems, depending on the company portfolio of batteries. Let's imagine that you disaggregate the data and see what is the battery strategy for Tesla, the battery strategy for Nissan, for Renault, for all the big actors in the EV industry, and to try to decipher what would be the impact in terms of OEM strategies.
You mean that? Okay. You mean that there would not be a global recycling strategy, but that companies on their own would
that's because the responsibility of the recycling is not aggregate at the level of the region or the country. It's the OEM responsibility. So
yes.
each OEM has to prove that he has managed its own fleet.
Yeah,
so,
it's actually the case for, I mean, there is actually a regulatory structure for all recycling activities in Europe, and it's declined by countries. So it's a producer responsibility standard, and it's declined with producer responsibility organizations that are more or less focused on how you will manage recycling and end of life of your material when you're a producer of this material. And so, yes, I think it will be interesting to maybe tackle from the perspective of one actor who has actually one type of batteries in its portfolio, and what will be its strategic decisions if this actor decides to recycle only what he produces. And so I'm not an expert on the specific portfolio of actors, for example, like Tesla, as you mentioned, but I imagine that they have like very specific power needs for their vehicles. They do have very specific battery needs, and it will mean that they have they would need to reach different different strategies in terms of recycling. And maybe on the level of one company, it would have some sense to analyze, as we said in the previous slide, the strategic choice of conserving a waste pool and strategically stockpile this waste pool to recycle later on and meet recycling objectives. However, this is not, I mean, in other industries, this is not especially the case. So in other recycling industries, usually the fact that you impose a producer responsibility organization, it forces all the actors to sit at the same table and discuss and also put in place a maybe coordinated recycling strategy.
My personal experience on that is that the main actor in the room, which is Tesla, don't want to discuss with anyone, and they want to manage their ecosystem alone. Okay. And their main reason is they think that their batteries are better than the rest of the batteries industry, and as they are very cobalt rich, they don't want to share this cake with, let's say, low quality batteries like the Renault or the Fiat, etc. ones. So in fact, there is a potential strategic game between high-end companies with very high quality materials and some others with less quality materials, let's say.
Okay. And so, and now it makes me think that I would add that what happened for the charging standards maybe should give hints on how these actors will behave with each other.
But just to congratulate you, because it's a very difficult topic, and you treat it very nicely. I think you should keep on working and finalizing the paper and try to publish it in a nice review, because it's a very timely topic. So don't let it sleep too long in your computer, and try to get it out.
Yeah, thank you very much. I see that Quentin raised an hand.
Yeah, just a couple of remarks. It just first, it is related to the second use of batteries. I think it's very unlikely that demand for stationary storage would be comparable to the flows of used batteries. So, and that's why we didn't put additional but extension of lifetime too big. But I mean, a way of doing that in the model would be to have a separate flows of used batteries that would be going to stationary recycling. And a second remark would be to how do you work with mandates on recycling when you have heterogeneous actors such as Tesla with high quality batteries and Fiat? I think you could think of something which is similar to the fuel standards actually in Europe, which is complemented by a credit market. As until before Stellantis merger, Tesla was selling a lot of credits to Fiat, for instance. So it would be the same if you have an OEM that recycles more, it could sell the credit to another OEM that doesn't manage to have to meet his target of incorporated materials. But anyway,
the only problem is I think that the rules are not, or that you have to recycle 100% of the battery. So anyway, you have to recycle. So you cannot sell the credits, by the way. You need to control every battery that you have sold and prove that after the first, second, and third life, you have managed all the components.
Sure, but the rule of the point that we assess from the European Commission proposal is related to incorporated recycled materials in new batteries.
Okay. You make the point.
But, thanks for your remarks.
Yeah, thank you. And I see there is also one question from Joe.
It's less of a question than a comment, because I live in Australia, and Australia is very much growing in its lithium exports and its industry, particularly, I guess, to China more than any place else. So I was kind of curious about where you think this growth in the industry is going to be stopped at some stage, or, just a quick comment on that, that's all.
Well, concerning lithium, maybe I can share again the slides. You can see that, lithium is still more or less used in every technology, even for solid state. So it's on the far left of the screen, even for solid state material. So what we can guess is that lithium is and will remain, at least with these technologies listed here, really in place in terms of growth of the market for batteries and for minerals needed for batteries. And the switch actually of minerals is more focused on the nickel, manganese, and cobalt conundrum between those three. And
yes, that makes sense. Thank you.
You're welcome. Thank you for your remark. So,
is there any other question? Okay, so if there is no other question, Etienne, I think we can end up the session here. What would you say?
Yes.
So
agree.
for the speakers, don't forget to upload your presentations, and thank you very much for this session.
Yeah, thank you all.
Thank you.